Hello, welcome to the third video in Quantities in Chemistry. In this one we're going to learn how to change mass to moles and moles to mass. So, since 1 mole of substance refers to both a mass of the substance and a number of particles, remember when we did molar mass, and the number of particles in terms of Avogadro's number of the substance moles, we can calculate one from the other. Now let's just do a quick example and we'll see how it's done. Ethanol, C2H5OH, is found in alcoholic beverages. If one such beverage contains 4.6 grams of ethanol, how many moles does this represent? Now we're going to use this formula here where N is the number of moles, M is the mass, and M is the molar mass. And this is what they've done it here. The mass is in grams, remember, not kilograms as we use in physics. So 4.6, the molar mass, if we added up all the carbons, hydrogens, oxygens and hydrogens, we'd get 46, and therefore that represents 0.1 mole. Yep. So now you should be able to do these questions here, calculate the amount in moles using that formula, recognizing that in each case you've got to calculate or work out a different molar mass for each. This guy here, now just remember that this is the hydrated ionic compound, so you've got to include the water in the mass because that adds to the mass here. And we'll be doing more questions involving these guys later on in the course. Let's do another one. In this case we're calculating mass from moles, so we know how many moles we have and we want to work out how much mass or in grams that might represent. So acetic acid has that formula. It's used to make vinegar when it's dissolved in water. It's what you put on your chips. 3.5 moles of acetic acid was used. What mass was weighed out? Now this is a liquid, but we can still weigh out a liquid. And again we're using our formula here, which is on our information sheet, and we've rearranged it, brought the M across to here by multiplying, which leaves M by itself, and so M equals N times capital M. And we've got the number of moles, 3.5. We worked out the molar mass of acetic acid by adding them all together to get 60, and we get 310 grams. That's how much needs to be weighed out. Now you can do all these questions here. Can't see too many tricks in those. You just got to be careful at doing them. Now doing these might seem a little bit repetitive, but when we move on to the topic called stoichiometry, you really need to be able to do this sort of stuff in your sleep. It's just it's like learning how to write ionic formulas and getting correct formulas. It's a basic skill that you need to be able to do well. So yes, it's tedious, but you need to be able to do it. Calculating mass for number of particles. So in this case we're given the number of particles, so we're going a little bit further here and we want to know what mass it is of hydrochloric acid. And so we go back to a formula we used a while ago where we've got N equals little n times by Avogadro's number, so that would be the number of particles, and then this N here goes into this formula here. So first of all we need to work out how many moles we have. Number of moles. So we've got the number of particles divided by Avogadro's number, gives us half a mole. Then we can put that into here because half a mole is that. Now we're after the mass, which is this guy here, little m, so we rearrange it into this formula and we put our known numbers in. The 36.5 is hydrochloric acid and we get 18.3 grams. So this question is a two-step question and you just recognize that and you can work it out. So we have this diagram here, which is in your textbook, but basically we're using these two formulas, so it's a good idea to practice using these formulas, and that's why I give you these questions to do. Alright, and here's some more questions. Again, a basic skill of being able to do, which is important. So it gets a bit repetitive, but you need to be able to do it and understand what you're doing it. We're going to give you this sheet in class. Here you've got a substance, and it gives you the formulas, which is handy. You've got enough information, alright, plus the formula and what the formula tells you. So the molar mass, for example, you can work out the molar mass for all of them, and then you can fill in the rest of the table by using those formulas that we've been using before, and it's good practice again. Now in the next video we're actually going to do something called percentage composition. Cheerio!